Hello students, pleasant greetings to you all. Welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video, which is part 3 of three-part series in our videos where I discuss solving simple linear multi-step equations. Of course, in part 1 we had looked quite quickly at how to solve simple linear equations involving one unknown and requires only one step involving addition and subtraction. Of course, in part 2 we looked at splitting the product and also solving multi-step equations using one unknown but more than 2 steps. So be sure to check out those 2 recently uploaded videos. You can check the algebra playlist that will be linked in the description, and I believe I should be seeing a card popping up at the top and right on the screen here that could take you to that playlist on algebra. Now, of course, in this video now we're going to be looking at how to remove say the denominator from an equation, as well as working some advanced questions. Now, after watching this video, my whole aim and focus here is to ensure that going forward you have not only the tools to help you to solve any and every equation that you may meet up into the future, but also to have a strong foundation when it comes to solving all types of algebraic equations. So of course, if this is the first time here on the channel, do not forget to hit the subscribe button below, turn on your post notification bell for daily and weekly uploads, and of course share this out to your mathematics community, as well as hitting the like button. It really does help the channel to grow. Now, the main purpose and aim of my channel is to give Caribbean students who are competing or who are doing their external exams on a yearly and a quarterly basis, students doing exams in January as well as exams in May. These video tutorials are very useful in giving you the ultimate preparation for exams, as well as any problem areas that you might have in algebra. I do hope that this video is of great value to you. So let's jump into today's lesson then. Now, as you can see from the heading there, that we're going to be solving equations involving fractions and brackets, and also we're going to be doing some advanced questions. So we're going to be here for about 45 minutes, so let's get into it. So here what we're looking at is example number 1, where we have x over 3 is equal to 5. So how do we actually solve this equation? There's actually 2 ways to do this. One is, of course, my personal preference, and the other one can be used at your own preference as well. So here, for me, this is how I would take on this question. I would therefore go ahead here and say that I'm going to be multiplying both sides of the equation here by 3. So if I multiply the left side of the equation by 3 and I multiply the right side of the equation here by 3, then this 3 will cancel this 3. So I'm therefore left with x is equal to 15. All right, and that's very simple way to work the problem. All right, now we can in fact work this equation yet again another way, and this is traditionally what you're going to find a lot of students do. They do what is called a cross multiplication technique here. So here what we do is that since the x has a denominator of 3, we can simply give the 5 its own denominator here and put it over 1. Then we can simply cross multiply. So that's x multiplied by 1 is x, and 3 multiplied by 5 is 15. All right, so we can pretty much get this answer in 2 steps, while it takes 3 steps to get to the next answer then. All right, so they are more or less the same. Now, why I do not like method 2, because in order for you to execute a cross multiplication, there has to be a 1-to-1 ratio relationship between the left side of the equation and the right side. So I find that the method 1 here is more effective, as you're going to see throughout the rest of this video here. All right, now we're looking at another example then. Say here y divided by 4 is less than or equal to 7. Same procedure. I'm going to multiply both sides by the denominator here. Okay, so therefore I'm going to say 4 multiplied by y over 4, and that's going to be less than or equal to 7 divided by 4. All right, so this 4 cancels this 4. I'm therefore left with y is less than or equal to 7 over 4. So I'm going to be using this method here at all times. I'm always going to be multiplying by the denominator. That's the very first thing that I'm going to be doing. Now here, very simple, same procedure here. We're going to be multiplying both sides by 5. So we end up, say here, with 2a. We're going to say 5 multiplied by 2a over 5 is equal to 6 multiplied by, say here, 5. So this 5 cancels this 5. We end up with 2a being equal to, say here, 30. Now this requires an additional step, because now if we have watched part 2, we would have learned how to split the product here. So then we're going to go ahead and say 2a here divided by, say here, 2, and that is equal to then 30 divided by 2. So here cancel. So a then is equal to, say here, 15. All right, so as we go deeper and deeper into solving these types of equations, you're going to then find that it requires more than one step to get to your solution. Now, moving on, as we go through these examples, you're going to see that the questions are going to get progressively more challenging. Now, here is where I would love to employ the cross multiplication method here. All right, because now I can clearly see that both fractions on both values on both sides of the equation has a clear denominator. Now, I'm going to be doing it 2 ways. And again, leave it in the comments down below. Let me know what method you prefer. All right, so here I'm going to be using the cross multiplication here. So I'm going to go ahead and multiply the 5 by the 4, and then I'm going to multiply this 3b by the 9. So I'm going to start with the b here. 3b multiplied by 9, that's going to be 3 times 9 is 27b, and then that is equal, pardon me, not equal, but it's actually greater than 5 times 4, which is, say here, 20. All right, and then of course to split the product between the 27 and the b, we're going to divide both sides by, say here, 27. So that's 20 divided by 27. Cancel. So therefore then we have b being equal to 20 over 27. All right, so pretty easy there. But again, I want to use this method. This method over here is what really gives me a better advantage as I go into harder and more challenging questions. So here what we're looking at then is using method 1. I use method 2 for this solution here. So now I'm going to be trying to get rid of the 9 and the 5 at the same time. So here what I encourage my students to do is that I encourage you all to find the LCM here. So now I know that the LCM of 5 and 9 is 45. Okay, so I'm going to be using 45 to multiply both sides of the inequality here. So I have 45 multiplied by, say here, 3b over 5, and that's going to be greater than 45 multiplied by 4 over 9. Now I'm going to go ahead then and I'm going to cancel the 9 and the 5. So 5 into itself one time, 5 into 45, 9, and 9 into itself one time, and 9 into 45, 5. So then all I'm going to do here now is just simply multiply the 9 by the 3. So I end up with, say here, 27b. And then I'm going to go ahead and say 5 times 4 is 20. So you're going to see that we kind of get the same result here. We're going to end up then easily that if we divide both sides by 27, that is 27b divided by 27 is equal to 20 divided by 27. Easily then we can see that b is equal to, cancel, 20 over 27. Now, whilst many students may think that this method is a little bit more challenging, then you're going to find that as you go deeper and deeper into the equations, you're going to find that this method is, even though a little bit more challenging and maybe a little bit more confusing, it is far more effective when the question becomes more complicated. All right, so of course, if you're getting some value already, guys, do not forget to hit the like button. It really does help the channel to get on the YouTube algorithm, and it really does help the channel to grow. So before you leave this video, be sure to hit that like button there. All right, so I'm just gonna go ahead then and move on to the remaining questions then. Now we're gonna look at an example then where, say here, 2 divided by t is equal to 14. Now what we have here is in fact the subject being at the bottom of the equation. Now once you have a student having the basic understanding of multiplying by what you do not want, then I've asked many students in the past, how do you approach this question? And statistically, I find that many students don't realize that you're actually having to multiply both sides by t. Now, most times, because of the language that we use, normally when I tell a student that I'm going to multiply both sides by, say for example here, I multiply both sides by 45 to get rid of the 5, what they think is that the 5 has gone. The 5 has not gone. All we've done is that we've cancelled the 5 from the bottom. Okay, so here, when I ask a student to simplify this sort of equation, their first response is that they're going to multiply both sides by 2, because their focus is that they want to get rid of the 2 from above the t. Remember, the aim is not necessarily to get rid of what is connected to the subject. The aim is to get rid of what is at the bottom of the equation. Okay, so it doesn't matter if the subject is at the bottom of the equation or the subject is at the top of the equation, you're still going to multiply both sides by whatever is at the bottom. So here what we're going to have now is that t is going to multiply 2 over t, and then that's going to be equal to 14 multiplied by t. Now you notice that the t pretty much disappears from the left side of the equation, but it automatically lands on the right side of the equation. So then we end up with 2 being equal to 14t. So we really haven't gotten rid of the t. We have just removed the t from the left and put it on the right. So now we're going to have to split the product again. So that's going to be 2 divided by 14. And then that's going to be equal then to 14t divided by 14. So cancel. Therefore, we end up with 2 over 14 is equal then to t. All right, and that is how you'd solve this equation. The most important thing from this sort of equation here is to ensure that you multiply both sides of the equation by whatever is at the bottom of the equation. It doesn't matter if the subject is at the bottom or a term that is connected to the subject is at the bottom. The aim is to get rid of what is at the bottom of the equation. Now, of course, there's always an alternative route around this, and this is when you really have an understanding of what you're doing then. Okay, so the same question here we have is 2 over t is equal to, say here, 14. What you can do is that you can multiply by the reciprocal of what is at the top. So since the number at the top is 2, I can multiply both sides by the reciprocal of 2, which is a half. So I can say a half multiplied by, say here, 2 over t, and then that's going to be equal to a half multiplied by 14. Now this is a bit more challenging. This is for students who actually knows what they're doing. So by me multiplying both sides by a half here, you realize that the 2 here cancels the 2, and now I'm left with 1 times 1. So this is basically 1 over t. So I'm going to have 1 over t, pardon me, running out of a bit of space here, guys. So I'm going to end up with, say here, 1 over t, and that's equal to a half of 14 is 7. Okay? So therefore then I can swap the position of the t and the 2. So I can cross multiply then. So the 7 goes down and the t goes up here. So I'm going to end up with 1 over 7 Once the 7 goes down and the t goes up, I'm going to get 1 over 7 is equal to, say here, t. Alright, so my final answer here is 1 over 7. I actually did not reduce this fraction here. You'll see that it's also 1 over 7, 2 into itself 1 time, 2 into 14, 7. So t is actually equal to 1 over 7. So this method here, I've never really seen anybody employ this method, but it's just important for me to show you multiple ways how to go around these types of questions. All right, but I'm going to be sticking, for the purpose of the video, I'm going to be sticking with the most effective methods. All right, just had to show you that there was a possibility that you could multiply by the reciprocal of the number that is above the subject. It requires a little bit more thinking, a little bit more understanding, but it's an option, so ensure that you put that in your bag of tricks. All right, now we're going to go on to some more advanced equation. Now this is where everything that you've learned in part 1 and in part 2 will be needed to apply. So let's walk you through the process of this particular question then. All right, now as we had discussed, the moment you get an equation like this, the very first thing to do is to keep your eyes on the prize. The eyes on the prize here is to get x as the subject. Okay, we need to find the value of x. Now, of course, my first problem would have been to get rid of the 3 and to get rid of the 2. The moment you get an equation and it has a denominator, the first aim here is to get rid of the denominator. Cancel the denominators. As opposed to using the word get rid of, we're going to cancel the denominators. Now, here, the LCM of, say here, 2 and 3 is equal to 6. All right, so the LCM of 2 and 3 is equal to 6. Now carefully guys, the equation must be kept balanced. That means we are going to multiply each and every term in the equation by 6. Now here I'm going to have 6 multiplied by 2 over 3x. Take away 6 multiplied by 4. That's equal to 6 multiplied by 5 over 2x minus 6 multiplied by 1. So the 6 is used to balance the equation. So the purpose of using the 6 was to cancel the 3. 3 into itself 1 time, 3 into 6, 2. Then I'm going to cancel the 2. 2 into itself 1 time and 2 into 6. 3. That pretty much removes my denominator. Then I'm going to go ahead then and I'm going to say here 2 times 2x, that is going to be 4x. Then I'm going to have 6 times 4 is 24, and that's going to be equal then to 3 times 5x is 15x, and 6 times 1 is equal to 6. Now that we have a straight line equation here, remember that we did this in part 1 and also in part 2 we learned how to transpose like terms. Now the question here, do I bring the 15 to the left side or do I bring the 4x to the right side? As we mentioned in part 2, you can bring it to either side, but prepare to deal with the fact that if you're working with an inequality and your subject has a negative coefficient, you have to remember to reverse the sign. We're dealing with an equation here, so bringing the 15 towards the 4 or the 4x towards the 15 will not change the end result. So here, I'm just going to bring the 15 over here, all right? And that's going to be 4x. If it was a positive 15, it becomes minus 15x. And then I'm going to go ahead then and leave the negative 6 over here and bring the negative 24 to become positive 24, all right? So therefore, then we're going to have 4x minus 15x is negative 11x, which is most times what I want to avoid, especially when it's an inequality. I do not want to have to deal with a negative coefficient. Nevertheless, that's what we have now, and that's going to be equal then to negative 6 plus 24. That's going to be equal to, say here, 18. All right, so now to split the product between the minus 11 and the x, we're going to divide both sides by minus 11. And as I said before, and I've repeatedly said, once you're going to be dividing both sides of an inequality by a negative coefficient, you have to reverse the sign. Now, this is an equation, so we don't need to reverse the sign, but we just want to practice to always try to keep your subject positive. Negative 11 cancels negative 11, therefore x is equal to negative 18 elevenths. negative 18th, 18th, 11th. All right, that is your solution then. All right, so nice problem there. Hope that you got some value from that. Let's see if we can apply this very same concept here to this equation then. Again, when you look at this problem here, the problem immediately that needs to be solved is cancelling the 9 and cancelling the 4. So once again, 9 times 4 is 36. I'm going to go ahead and multiply each and every term here in the equation by 36. So it's going to be 36 multiplied by 5 minus 36 multiplied by 2t over 9. That's less than or equal to 36 multiplied by 3 over 4, and that's going to be 36 multiplied by 3t. All right, so now if we have this equation, now we can go ahead and cancel what can be cancelled. So we're looking at, say here, cancelling 9 into itself one time and 9 into 36 4, and 4 into itself one time and 4 into 36 9. So we end up with 36 times 5. That's going to give us, say here, 36 times 5. That's 180. 4 times 2t, that is 8t. And that's less than or equal to 9 times 3 is 27. And 36 times 3t, that's 108. Let's double check that. That's 108 t. All right, now once again, when you're practicing or when you're even doing an exam, you have to concentrate and you have to pay close attention to what you're doing. Here I can immediately remember from my very intense practice sessions that I'm dealing with an inequality. So in this case here, I'm always going to try to remember that I want my subject to be positive. So do I bring the 8t over towards the 108, or do I bring the 108 over towards the 8t? Well, they're both negative coefficients, and the larger the coefficient is when it's negative is the smaller it actually is. So therefore, negative 8t is actually larger than minus 108t. So in this case here, I'm trying to keep my subject positive. I want to make it easy for myself. I'm going to bring the negative 108 to this side of the equation then. So I'm going to end up with, say here, negative 8t plus 108t, and that's going to be less than or equal to, I didn't touch the 27, but then I'm going to simply move the 180 back over to that side then. So that's 180 becomes negative 180. So now I end up with negative 8t plus 180 gives me 100t. All right, and then of course that's going to be less than or equal to 27 minus, say here, 180. That's going to be negative 153. All right, so therefore then I'm going to split the product. I'm going to isolate the t by splitting the product. So that's 100t divided by 100, and that's less than or equal to negative 153 divided by 100. Again, I don't need to reverse my sign because my subject is in fact positive. If this was a negative 100, then I would have to turn the sign backwards. So therefore then I end up with t being less than or equal to 153 over 100, negative 153 over 100, and that is my final solution then. All right, so pretty good so far. Tricky question, but you can see very doable once you have all the rules packed down. Be sure to check out part 1 and part 2 of this video so that the level that we're at right now, you can effectively understand what is being done. All right, we're going to be moving on to another type of equation, a fractional equation involving binomial expressions. All right, I think I might need a little bit more space here, guys. So I might, okay, let's see how much space we might need. Again, immediately as I look at this question, the very first thing is that I need to get rid of the 4 and get rid of the 5. And again, the LCM of 4 and 5 is in fact 20. Now I can employ method 1 by multiplying both sides by 20, but this is a very clear indication that I have a 1-to-1 ratio. I have x minus 3 over 4 being equated to 3x minus 1 over 5. So I could just employ the cross multiplication technique here. Now, when we are cross multiplying involving binomial, remember that the number that is being distributed must be distributed to the two terms. So when I say 4 multiplied by 3x, which gives me 12x, I must also remember that the 4 has to multiply the minus 1. Now, just to prevent mistakes from happening, I kind of like writing down before I calculate. So I'm going to go ahead and put the 4 here. I'm going to open a bracket. I'm going to put this 3x minus 1. And then that's going to be equated then to 5, open bracket, x minus 3. Now, students might ask, why did you put a bracket as opposed to putting a multiplication sign? The bracket sends me the message from my previous study session on AP3X Institute of Mathematics Education, where whatever is on the outside of the bracket should be used to distribute what is on the inside. Please check out my distributive law video on my channel. I will pin a link in the comments down below for you, so do check out the video on distributive law. Once I'm dealing with a binomial expression, I'm going to have to put the binomial in a bracket. And what do I mean by binomial? We have two unlike terms that are merged as one. So what this means for me then is that I'm going to go ahead and distribute the 4 along with the 3x. Okay. Now again, if you know what you're doing, guys, you don't have to write it down like that. You can just go ahead and do your thing here. All right. So now 4 times 3x, that's going to give me 12x, and 4 times minus 1 is minus 4, and that's going to be equal to 5 times x is 5x, and 5 times 3 is in fact 15. All right, beautiful. So now I have a very straight line equation. Remember, the aim is to get the x's on one side and the numerical values or any other terms on the other side. So here it's very clear that 12 is larger than 5. So I'm just going to simply bring the 5x over towards the 12. So I'm going to go ahead here and I'm going to transpose the 5x over here. Okay, so I'm going to have 12x, take away 5x. And that's going to be equal then to negative 15. Negative 4 goes over, becomes positive 4. So 12 take away 5, that's going to give me 7x. And that's going to be equal to negative 15 plus 4 is negative 11. So splitting the product, isolating the x by splitting the product, I'm going to end up with, say here, if I divide both sides by 7, I'm going to end up with, say here, x is equal to negative 11 over 4. I do apologize for the chopped up work, guys, here. I really should have given myself ample space to work this out, but I do hope that you guys are following the steps as I go along. Please ensure that you're working these questions before I'm actually showing you the solution, so you can therefore match your solutions with mine. Or if you're working it out and you're stuck at a certain section, you can pause and unpause the video to match whatever upcoming solution with yours. All right, beautiful. Now we're going to go into a more one equation that looks a little bit more complicated than the others, right? It's not just a fractional equation, but it's fractional equation involving, say here, distributive law. Now, again, the aim here is to get rid of the 4 and the 3. So we're going to go ahead then and find the LCM of 4 and 3, which is in fact 12. So I'm going to go ahead and employ here, say, I multiply all of the terms in the equation here by 12. Now, something just came up, and a few of my students has asked me this in the past. What is the difference between simplifying an algebraic fraction and solving an algebraic fractional equation? Most persons will hear me say finding the LCM, but then they don't see me drawing a line like that, because I only draw the line when I am simplifying an algebraic fraction. I'm actually solving the fractional equation. So I don't write the line. I simply just locate what the LCM is and then employ the multiplication of the LCM with all the terms inside the equation or the inequality here. Okay, so I'm going to go ahead then. I'm going to use the 12. I'm going to multiply it, say here, by this 3 over 4. I'm going to go ahead then and say here, take the 12 again and multiply it by the minus 2, open bracket, x, take away 4, and then that's going to be less than or equal to 12 multiplied by 8 over 3. All right. So here, this minus 2, open bracket, x minus 4, they are actually merged together as a product. The 2 multiplies the x minus 4. So pretty much when I'm not going to multiply what is inside the bracket by 12, I simply just multiply what is on the outside of the bracket by 12. All right, so just be careful with that, guys. So then we're going to go ahead then and cancel out the 4. So we're going to say here 4 into itself 1 time, 4 into 12, 3. And then I'm going to go ahead and say 3 into itself 1 time, 3 into 12, 4. So let's see what we have after the cancellation. 3 times 3 is in fact 9. Minus 12 times minus 2 is going to give me positive 24, open bracket, x minus 4. And then that's going to be less than or equal to, say here, 4 times 8 is 32. All right, beautiful, beautiful, beautiful. So we're going to go ahead then and distribute then the 24 here. So we're going to distribute the 24 with the x here and the 24 with the minus 4. So we end up with 9 plus, say here, 24 times x is 24x, and 24 multiplied by 4, that sounds like about 96, and that's less than or equal to 32. Beautiful. So we're going to move this over here. Again, guys, I do apologize for not creating ample space for the solution, but I do hope that you guys are following as I try to be as neat as I possibly can here. So now the aim here is to get x's on one side. There's only one x that we're dealing with here, only one x. So we're going to leave the 24x on the left, no need to interfere with it. Then we're going to transpose then the 32, or the 32 is already on the right, so we're going to transpose the negative 96, we get plus 96, and we're going to transpose the positive 9 to the right side, we're going to get minus 9. So if we hop onto our calculator here and we type in 32 minus 9, or 32 plus 96, apologize guys, 32 plus 96 minus 9, we end up with 119. So that's 24x is less than or equal to 119. So if we split the product between the 24 and the x, we end up with x being less than or equal to 119 divided by 24. All right, divided by 24. Fantastic. And that is our final solution. Now if you notice, guys, that all my answers that I'm getting, they are not the traditional answers that you're going to find when you go into a textbook, or you go into Google and you search for worksheets on simple linear equations. Most times you're going to get really nice answers. These questions were made up by myself here, and I just wanted to apply or show you the process of simplification as opposed to trying to get really nice results. All right, so when you get results like those, do not feel like they are incorrect. All right, remember that I'm teaching my channel primarily based on teaching Csec, CCSLC, SEA students exams, Caribbean exams. These problems can help many students across the world, but primarily because I'm so accustomed to many of my students making these mistakes and having these doubts, my video is specifically made for these types of students who have these many concerns. All right, let's move on then to our final page here. We're going to be looking at some more advanced questions, and after these 3 questions, it should really take us into the end of this video here. So let's quickly run through these. So now what we're looking at here is brackets and fractions. So now we only have one denominator to pay attention to here, which is in fact the 2. So now here we're just going to be multiplying both sides by 2. So that's going to be 2 multiplied by the 5 on the outside of the bracket, and that's going to be 3x minus 1, and that's going to be less than or equal to 7 over 2 multiplied by 2. All right, and so of course here we're going to have cancellation. So 2 cancels 2, so we end up with 2 times 5 is in fact 10, open bracket, 3x minus 1, close bracket, is less than or equal to 7. All right, so now we end up here with 10 times 3x is 30x, and do not forget to distribute the 10 on both terms. 10 times minus 1 is minus 10, and that is less than or equal to, say here, 7. Easily now bring the 10 over to that side, so that's 30x is less than or equal to 7 plus 10. We end up with 30x being less than or equal to 17. So easily then divide both sides by 30. X is less than or equal to 17 divided by 30. We already know that once we divide both sides by 30, the 30 on the left will be cancelled, both top and bottom, and so easily then 17 divided by 30 is our final result. All right, so pretty easy there, not too bad. Here's another example where we're dealing with two numbers instead, 5 and 3. So we need to we need to solve for, we need to get rid or cancel the 5 and the 3. Now I do strongly recommend though that what I like for you to do, guys, is, well, let's just continue with what we were doing. We're going to be finding the LCM, which is 15. So that's going to be 15 multiplied by the 3 that is on the outside of the bracket here by b minus 1 all over 5, and say here 15 multiplied by the 2 outside the bracket, open bracket, b plus 2 all over 3, and do not forget to multiply the 11 by 15. All right, now here say if we can go ahead and cancel. So that's 5 into itself one time, 5 into 15, 3. And so we can say 3 into itself one time, 3 into 15, 5. All right, so we end up with 3 times 3 here. Just focus, guys. 3 times 3 here is 9. And then so the 9 that we have on the outside of the bracket here will be distributed inside. So 3 times 3 is 9. Let's go ahead. 9 times b is 9b. And again, 3 times 3 is 9. 9 times minus 1 is minus 9. Take away here. 5 times 2 is 10. So the 10 will be used to distribute what is on the inside. So 10 times b is 10b. And of course, 5 times 2 is 10. 10 times 2 is in fact 20. All right, so if you're not able to handle like these little steps here, guys, then you have to revert back to trying to make the question simpler for yourself. What I do recommend that some of you students do is that try to get rid of the bracket first, okay, before you do any sort of simplification. So if I was at a different level than where I'm at now, I would perhaps be tempted to say, hey, let's get rid of the 3 first. So 3 times b, 3b. Then 3 times 1 is minus 3. 2 times b is 2b. 2 times 2 is 4. And then I would go ahead and multiply the whole equation by the LCM, which is 5 and 3. But, I mean, at the end of the day, this video is for advanced students. So once you're at this level and you're struggling with solving fractional equation, then this video is definitely for you. So here we're going to be, that's going to be equal. Is it equal? Yes, it's equal to, oops, let me get back my same color marker here. All right, and then that's going to be equal then to 165. All right, so now what we have now is to get the b's on one side. So we already have them on the same side. So that's 9b beside beside minus 10b, and that's going to be equal to 165. I'm going to transpose then the 20. That's minus 20, and I'm going to transpose the minus 9. It's going to become plus 9. So 9b minus 10b is negative b. This is what I was trying to avoid. I never like to have a negative sign in front of my subject, but nevertheless, that's what we have. Negative b is equal to 165 minus 20 is 145, and 145 minus, plus 9 is equal to 154. Okay, so that's 154. Okay, beautiful. All right, so if we have negative b is equal to 154, therefore it is easy to say that b is equal to negative 154. Just dividing both sides of the equation by negative 1, and so we end up with a final solution here of b is equal to negative 154. All right, now we have this final equation here to solve. Okay, so now all we're going to be doing here is, let's just get rid of the bracket from now. I want to make this process as simple as possible. Okay, so when we get to that point, we're going to just distribute here. All right, so let's just do it from now. 4 times x is actually going to be, so negative 4, pardon me. Let's put our sign, our distribution line properly. So it's negative 4 by x and negative 4 by 1. So right here, I'm just going to go ahead and put negative 4x plus 1. So when we get to that stage of multiplication, we know exactly what we're going to be doing then. All right, so here we go. The LCM here is 2 and 5, so that's 10. So I'm going to use the 10 to multiply, say here, the 3 over 2 x, and then we're going to use the 10 to multiply the 5x. So we're going to be using a bracket here. So that's 10, open bracket, 5x plus 4 all over 5. Okay, remember that once it's a binomial, we have to use a bracket. That's going to be less than 10 multiplied by 3 minus 10, open bracket, negative 4x plus 4. Remember that this is a binomial, so we're just going to go ahead and multiply it by 4x plus 4. If you wanted to, you could just multiply the 10 by the 4 immediately and write 40x, and then 10 multiplied by 1 gives you minus 10. So if you want, you could have multiplied both of these by 10. All right, let's continue then. All right, so this cancel here leaves 5 cancels here, leave 2. All right, so let's go. So that's 5 times 3x, that's 15x minus, let's distribute, minus 2, this is the minus here, don't forget the sign, minus 2 multiplied by 5x, that's minus 10x. And remember, it's minus 2 on the outside, guys. Okay, let's just make sure that we bring that 2 down a little bit closer here. So it's minus, this minus here belongs to the 2, minus 2 times 4 is minus 8. Remember, it only takes one wrong sign for everything to be incorrect. So we've got to be careful when we're distributing. So that's less than or equal to, say here, 10 times 3 is 30. And we can go ahead and distribute the minus 10 here. Minus 10 times minus 4. That's going to be equal to positive 40x. And negative by positive here is negative 10 times 1 is 10. All right, beautiful. Not too bad. So now we just need all the x's on the left side or the right side. It's an inequality, so right away I'm thinking that I need both the 15 and the 10 to be on the side of the 40. I don't want to have to reverse my sign if I don't have to. So I'm going to leave the minus 8 all the way over here. I'm going to bring the negative 10 over. It's going to become positive 10. And then I'm going to bring the 30, this is a numerical value, over to the left. It's going to become minus 30. That's going to be less than or equal to the 40 is already on the right side. I'm going to bring the negative 10x now over to the right side. That's going to become positive 10x. And I'm going to bring the 15, the positive 15 over, it's going to become minus 15x. So now I have all the x's on the right and all the numerical values on the, say here, left. So now what I have now is negative 8 plus 10 is 2. And 2 take away 30 is negative 28. And that's less than or equal to 40 plus 10 is 50. 50 minus 15 is 35x. All right, and then easily then we can divide both sides here by 35. So we end up with 35x. Let me just write it accordingly. So I have negative 28 divided by 35 is less than or equal to 35x divided by 35. So easily then we can cancel, and so here cancellation 35, 35. Therefore our final result is x is in fact, let's just write it accordingly. So we can cancel the 28 and the 35. 7 goes into 35 5 times. 7 goes into 28 4. So we have negative 4 over 5 is in fact less than or equal to x. And that is our final solution then. Alright, nice way to end this question here, getting a very common fraction, very common proper fraction for our answer. All right, so I really do hope that the video here really highlighted many of the inconsistencies that you've been having. I really do actually hope that you guys try to work the questions before looking at the solution, because that's the only way that you're going to be able to master your own skills. You've got to be able to make the mistakes, guys, and then seek the solution as opposed to watching the solutions first. All right guys, so I really do hope that this video was of some value to you. Please be sure to hit the like button. Do not forget to share this out to your math groups, math communities, math friends, anybody who you know may be struggling. Leave some positive questions and comments down below, and do not forget to hit the subscribe button. So until next time, take care. I'll see you in a future tutorial. We're going to be looking at transposition of the formula involving roots, powers, and factorization. So until then, take care. Bye bye.